On the Siemens booth. For those of you who are wondering, Vivek is from one of my favorite places in India, just south of Goa, one of the beautiful beaches over there. But this isn't about Goa, even though I want to go surfing right now. This is about Siemens technology, and we're going to talk to you first before heading back to the boardroom with my buddy Chris back there. Vivek, let's talk Siemens, shall we?
Yeah, so glad to have you here, Tony. We've been planning this a long time, and welcome here to the Siemens booth. And today we're going to talk all about empowering digital manufacturing, and be ready to be surprised.
Oh, you're going to be surprised. We have a lot of technology for you. Empowering digital manufacturing. What does that mean to you, Vivek?
It means getting data down to manufacturing and bringing real use to it, the real benefit to the operator, to the machine builder, and everyone who's part of this chain of the part production.
Absolutely, perfectly said, Vivek. I'm going to go to the boardroom now, join Chris. Guys, come with me. I want to show you something real good over here. Chris, we're doing all right. This is the CNC guy. He's got about 2 million views on his YouTube page, about 6,000 followers. You can check that out as well. But again, let's get back to Siemens, shall we?
Absolutely. So, what's the worst things to do when you're in this show is just show off, oh, this is our latest project, right? This is the newest thing we got to show. We'd rather look at what are the challenges our customers facing, right? So let me ask you a question. You just bought a CNC machine. What's the worst thing that could be happening to that machine?
I know this answer because he queued me up ahead of time because I can think of a lot of bad things, but it's not running.
Absolutely, right? I mean, we buy this machine to make us money. That's key. Well, if that spindle's not spinning, if I'm not making chips, I'm not making any money. So we want to kind of take a look at why it's not running. Now, yeah, it could be something like staying down for maintenance, God forbid, maybe I don't have any jobs, or I'm in the process of setting up a new job. Now, yeah, for a small shop or any shop for that matter, those things could be out of his control. But one of them's not, and that's the setup process. So we wanted to explore that a little further, and I got a couple slides up here we're going to talk about a little bit. And this is what we consider the traditional CAD/CAM process chain, right? So if I'm going to manufacture a part, I'm usually going to design it, or maybe I get the design from my customer, depends on what we're doing there, but I'm going to push it into CAM. Then at some point, we'll maybe drive some simulation and drop it down on the machine floor. Now, obviously, you can see this is a very sequential process. So what happens is there is an issue in any piece of this chain. Well, now I got to start almost from the beginning again. Well, at this point, it doesn't make sense to reset up the machine, so now she's sitting idle. So how do we take this process and kind of adapt it so maybe we can really optimize the flow? So what we did, we said, okay, well, where are the challenges coming from? So first, when I'm up in my programming department, I want to see what's going to really happen down on that machine tool floor. However, there's a lot of challenges when starting to look at the whole digital twin concept, right? We hear all about that these days. So we want to take a look and see, well, what can we do so the programmers know exactly how that machine's going to behave? And even beyond that, how do they know what the quality of the part's going to look like even before we've cut the first chip? Now, at that point, we're probably ready to start setting up the machine, dropping in some tools. Well, what's the worst thing when I know I need that half-inch end mill, and boy, it is nowhere in the shop to be found? I'm going to buy another one, right? So the consumables are a big piece of the manufacturing process. So with that, what if we can figure out a way to track our tooling better, maybe take the human element out so an operator doesn't mess up putting an offset into a control? And now we're going to start running production. But with the production side, I want to make sure I can maintain that quality. So we're going to look at some solutions and talk a little bit about that, how we can ensure the right jobs.
And you have some friends and partners in other parts of this booth that we're going to talk to. So for those of you watching right now, if you have a question about any of this that Chris went through, send your questions in. We can answer them simultaneously while we're live streaming this event. But with this being said, let's send this over to Joe to follow up on Chris's cue.
Thank you, Tony. I'm here with Dan of Siemens, and we're going to be talking about Run My Machine initially. Why would people why are they looking for this software to implement digital twins?
So Run My Virtual Machine is something that we have a new product with Cinemeric 1, and what this is actually got the brain of the control sitting here on my PC, and we're able to simultaneously run the code that I've taken out of the CAM system and verify if any crashes, if there's anything wrong with the G-code programming that I put out of the CAM system, if there's anything with the tools and the length of the tools and our whole job setup here. So it really gives the capability of going through the whole program and making sure there's nothing wrong with it, so that when I put it on the machine, there really is a really ease of use and I can hit cycle start and go. So let me take you through that. So if we can just run through this, I can hit cycle start and it's going to go through and change, and we're actually going to just start to simulate it. And then here it can show that right off the bat we had a crash. And with that, we don't want to make sure that we're seeing that on the shop floor. So this would be something where I would actually lengthen my tool here so that we didn't have that on the shop floor. But
how about there's a lot of variables in play here, things like the post-processor and things like this. How is that factored in?
So when we post the code and we put it through this system, because we have the brain of the control on this piece of software, it will actually interpret it just like it would on the machine. So it would say that, oh, this is wrong with the post, or this is wrong, there's a syntax here. So this really is a nice thing, that when we look at what Chris was saying as some of those key issues that we see on the job floor, that we can kind of do here without even leaving our desk. We haven't left our desk yet.
That's a big advantage of you supplying the software in this case, the drives, the controls. It's all coming from Siemens.
Yes, correct. So this is what I would say is a true digital twin, because one of the pieces of the puzzle that we have is we needed to have simulation for a digital twin, and we need to have the NC and the PLC, and that's this piece of software. So this piece of software has both. It has the NC and the PLC, so you're going to get a true, really one-to-one cycle time. But even because we have the brain on this piece of software, we can actually pull a trace out of that, and this is really what I like and what I'm really passionate about, what Chris said. So we post the code out and we run it here. We check the collisions, we check the code, it looks good. But how did it run on the machine? What did it do? So we can actually, sitting at our desk still, run a trace from our machine and look at load of the spindle, we can look at load of our drives, how it interpreted it and how it interpreted the code. And we can move that into a piece of software called Analyze My Toolpath. And when we do that, we can actually start to see some interesting things. So let's look at that. So when we pull up the software, all the way to the left is we actually have the G code that came out of the post processor. And then to the right of that is the actual trace coming out of Run My Virtual Machine. We've traced it, and the red and the green is how the control interpreted the posted code from the CAM system. And as you can notice, there's a lot of green in the middle of our part, and these might be gouges. These are slowdowns of the machine. So green is actually 50% reduction in the program and feed rate. And what that means is you might see a gouge there, you might see a little bit of witness mark, and this is really we go down to the control, we run the part, and then, oh, it's not good. We got to go back up to the programming room, we got to post it out again and go back down. But because of the technology cycles of our control, I just put in one line of code. I didn't change the program, I didn't repost it, I put one technology cycle into this posted code already, and we get a smooth transition and a really smooth part, and I didn't even have to walk down to the machine once. I posted that out and put that technology cycle in there, ran another trace, went back to Analyze My Toolpath, and I got a smooth part. Now I'm going to walk down to the machine and press cycle start.
And just quickly, just to wrap up, how much intervention from a human being?
One person. So really, how much intervention from
how much of this is operator intensive, programmer intensive?
Oh, not at all. So really, it's just setting up the trace and hitting cycle start, and then pulling that trace out. It's an XML file and dumping it in here. It's really easy to kind of see what's going on and visually see what you need to change.
There we have it. Thank you, Dan. Back to Tony.
All right, Chris, so we talked about cycle time discrepancies, surface finish anomalies. We're now going to move into managing tools between multiple machines. Would you actually define what that means? Because I know we're going to throw it over to get more details on it, but what does that actually mean to queue them up?
So, we have a lot of money tied up in tools. There can be all over the shop, right? Well, how can we automate that process to know exactly where the tool is flowing throughout the machine shop? So we've created some different software solutions that allow us to track tools, push data into the machines to take that human element out of it, so we can basically not incur the error of typing in the wrong offset. So we're going to jump over to my buddy Steve, right? Steve's our quote-unquote tool room manager, and he's going to show how we've optimized this process. And by optimizing it, we're going to save money, but more likely than not, we're going to reduce setup time, because we're going to have everything we need at that point in time.
Before we go over to Steve, Chris, you've never made a bad offset, have you? Never put that decimal in the wrong place? Certainly not me either. That's always been in the right place, right?
Only when I'm on camera.
All right, Joe, take it away, my friend.
Thanks. Thanks again, Tony. It's great to be here with Steve. Steve, what are we about to talk about?
Right now we're going to talk about management resources tools. This is an application that utilizes the ability to manage your entire tools on the shop floor, from tool inventory to offsets to connectivity to your machines and transferring back and forth.
Can we take a look?
Yeah, absolutely. So right now we're just looking at the main dashboard screen. You can see kind of across a variety of different applications you can utilize, whether you're looking at tool components, for example, and building your tool assemblies. And then I can even jump in and we can start looking at the tool stock and other applications. So what I'm going to look at right now is just the tool stock. At a very basic sense, these are the tools that you have available to you on the shop floor. You can filter these based on machine location. You can filter them to the lifespan of the tools. If you only want to look at the tools that are nearing their remaining life, you can do so. You can filter just by tool instance. So how many of these specific tools do we have available to the shop floor needs?
Do we, just on that, do we need full digitization, or can we have some manual input?
You have manual input. It's both. We try to make it as flexible as possible. So there's manual input. There's even REST APIs if you want to integrate into something that's more homegrown, for example. But we also have absolute connectivity to our shop floor. Another thing I want to highlight on this application is that you can also see the lifespan of the tool. So if we look on the right-hand side here, as you're machining with these tools, you also have the countdown during the machining cycle time. So once your machine is actually connected to the tool itself, it recognizes that, oh, this tool is being utilized. We'll do a simple countdown, for the tool lifespan, as well as a warning limit as to when the tool nears its end of life, because that's something you want to notify, right? As you're nearing your end of life, can we do our next jobs before our tool runs out, for example?
So what sort of input can we have? Can we use things like tool presetters, so we know length and diameter of tools, things like this?
Yeah, absolutely. I can actually show you the next slide here. It really leads right into it. That provide tool needs. This is essentially a Kanban board of telling you the cycle of the tool's life. So once when it first reaches the to be obtained stage, you're just gathering your tools, then you're assembling at the assembly tool crib, and then the to be measured stage, which I actually have a tool set up right now, that can integrate to an actual presetter. So once when the tool is measured at the presetter, it generates something called an INI file with all the measurements and offset data associated with the tool, and it uploaded back into the server. So you have that transparency of this specific tool instance, as well as the measurements associated to that tool.
So we're saying every instance, like assembly as I would call it, they're unique. So if I've got 5 machines and each has a 10 mil end mill, they're still going to be different tools.
Definitely. Each one of those tools has its entire life, and the moment it gets on the shop floor, it's totally unique, right? I mean, even if it's a manufacturer, you have some minor imperfections essentially. But yeah, that's why you want to measure the tool at the presetter, get that exact instance data, and have it live along the shop floor. And that's what it's all tracking here today.
Sure, and we've got one final slide.
Yes, correct. I have one final slide. And this kind of ties it all together. What I'm going to be showcasing here is the balancing functionality, because once you generate your bill of materials and you have all the tools needed on the shop floor, the next question is, are these tools available to you on the shop floor? And if they are available, where are they located? So I just made a very basic demo to set this up. We're going to kind of go through the process real fast here into the balancing function. I'm going to decide my machine location of where I'm going to place this tool. And it's basically asking ourselves, where is this tool located? Production order 1, 2, 3, that's fine. And here on this function, we're going to say, I need this tool, and I'm going to look for these different windows. Right now, by default, we're looking at a machine as well as the assembly tool crib, but I'm also going to add a different location. Here we're just going to add the cabinet next to the machine itself. And this is totally customizable to whatever use case you might be having. After I go to next, I can then see these are my tools needed for this specific job, but if you notice no new tool instance is needed, why is that? Well, for our tool reservations, we can see that we already have 3 tools available on the shop floor. No tool is needed for this new job because we can either locate 2 tools in the assembly room or 1 tool in the cabinet next to the machine that we're already looking for. So it really kind of eases that process of where my tool is located when it does it automatically for you.
Well done. That's a great explanation. Now back to Tony.
All right, Chris, we got to now talk about 2 worlds combined. Now, I don't think you're talking about surface Earth and journey to the center of the Earth, but you've got to be talking about something far more technical than that, right?
At least interesting, right?
Yeah.
So really what we're showing is our rethought out process of the CAD/CAM manufacturing process chain, right? By empowering the programming department, we can stay kind of within their world a little bit longer, but really start to ensure that when we get down on the floor, we can reduce that downtime. Now the next step in the piece is now we're really starting to produce some parts. So how do I manage to maintain the quality of these parts? You know, everybody hears about Industry 4.0, digitalization. So what does that mean? Well, what you tend to find is you jump in, you start grabbing all this data out of the machine, and you have no idea what to do with it. Well, we figured out something to do with it.
Well, it's about time somebody did. Thank you for doing that.
Absolutely. So what you're going to see is we're going to jump over to Gus. Gus is my IT specialist, right? He's the guru, and he's figured out how we can pull this data out of the machine and be monitoring the machine real time to ensure that we maintain the highest quality part within the spec that we need for our customer.
Absolutely perfect. Well, Gus, the guru, take this away, my friend.
Tony, thanks again. I'm here with Gus for the last presentation of this stream. Gus, what's all this about?
Okay, thanks. Yeah, so what I'm going to be going over is continuous process quality monitoring with our Cinemeric controls. This is going to be accomplished using our industrial edge for machine tools, which is Siemens Edge Computing Platform. It's essentially an industrial PC that you'd install in the machine cabinet. You have one Ethernet port that's going out to your machine tool. With that, we're able to collect high-frequency data at the position control loop cycle. On most machines, we're looking at about 500 hertz of data rate captured, such as what we're seeing on the machine behind us. Your other port's going to be going out to your shop floor network, so you can push this data out to your upper-level systems and do high-level analytics. So with this edge device, we've got edge applications running on top of it. In particular, what I'd like to go over right now is our application called Analyze My Workpiece Monitor. So how the application works is you can define different monitoring jobs that you want to monitor, when you're machining a specific feature, when you're tapping a certain hole, when you're running a certain end mill. And if you, from the data that you've collected off the machine, if you're staying within your tolerance band that you've set up for this monitoring variable, such as your spindle load or your contour deviation for surface quality finish, if you stay within your tolerance band, you essentially get a good report out. And if you have an anomaly during your machining process, you essentially get that reported back to the operator. You also have this report generated that can be pushed up to your own ERP or MES system or used to notify your maintenance department.
Well, when we look at this technology from Siemens, I find it breathtaking, I really do. Yeah, what size of business are we looking at? There's a perception you have to be a blue chip, huge company, but that's not correct, is it?
No, not at all. So the good news is with this edge device, we can install on just about any of our Cinemeric controls that are available after about probably 2014. So almost all of our 840D solution line controls. And because of the fact that this puts almost no load on the CNC, we're able to install in your existing installations without impacting the performance of the machine. So if you have a job shop where you have 1 to 5 machine tools, we can install one of these, get it configured on the machine in an hour or two, and you're up and running.
And what's the big advantage of basically digitizing our workflow?
So the big advantage is going to be the fact that you're doing continuous process quality monitoring. So instead of gauging 1 out of every 20 parts or 1 out of every 50 parts, we're able to monitor things like the spindle load and contour deviation on every single part that you're producing. So you have 100% quality monitoring. If you start producing bad parts, you can detect that early on in the process instead of producing an entire batch over a day and scrapping hundreds of parts.
And we can look at this retrospectively, can't we? It's one thing looking at the data now on the screen, but we can go back weeks, months, years.
Absolutely. So we have hundreds of gigabytes of storage directly on the edge device, and then beyond that, we're able to push this data up to your upper level systems via either MQTT or via a REST API within the application, so you can store it within your data lake for years and associate it with a particular part number. So if you start having problems or a recall with that part, you can go back and trace what exactly happened whenever you were machining it.
And just the final one for me, it appears futuristic, but it is here and now, isn't it? What's the market adoption like on this technology?
Actually, where we've seen our biggest market adoption is really in the aerospace and automotive verticals. With aerospace, a lot of it, we're looking at individual machining processes that they're really concerned with. With automotive, we're really looking at monitoring an entire production process for a single part and essentially identifying if we just see any anomaly or not. In the aerospace sector, we're also using this for machine health monitoring to basically identify if we're seeing mechanical issues with the machine tool.
I guess the bigger the process, machining or whatever the production is, I said the bigger the gains are going to be.
Absolutely. So to be quite honest, with this monitoring capability, if you're doing mass production, that's where you're going to see the most gains because we're able to go from, instead of just doing 1 out of X parts quality monitoring, doing 100%.
Thank you so much. Right now, back over to Tony, who's going to finish this live stream.
Big pimpin', spending G's, and we be. Chris, you ready to go grab that beer after that awesome live stream?
I am absolutely ready.
All right, 1, 2, 3, ski!